Hi everyone, and today's learning target is I can solve equations involving negative variables and fractions. So we are continuing with our equations lessons, and remember, we want to isolate the variable or get the variable by itself. The variable cannot be negative. So we will take a look at that today with many different examples. So let's take a look here at the first example. I see negative x plus 13 equals 23. So I want to solve for x. So the first thing I'm going to do is move over that 13. And the inverse operation of adding 13 is to subtract. So then I'm left with negative x equals 23 minus 13 is 10. And now I see I have a negative x variable, which I cannot have. And that also looks like a negative 1x. I just don't see the 1 in front of the x. So I am seeing that x is being multiplied by a negative 1, so I'm going to divide by a negative, or divide by a negative 1. And so the signs change, so my answer would be x is negative 10. And if I wanted to check my answer, I can plug that back in, and I will see negative 10 plus 13, if that equals 23, I'm right. And a negative 10 is really 10. So 10 plus 13 does equal 23, so I know I'm right. Now let's look at the next example. 15 minus x equals 30. So I want to solve for x, so I'm going to move over that 15 by subtracting it, and I'm left with negative x equals 30 minus 15 is 15, and the same thing now here we see as we saw in the last example, I can't have a negative variable, so I'm going to have to divide by a negative or divide by a negative 1, and I'm left with x equals negative 15. And again, I can check my work by plugging my answer back in for my variable. So 15 minus negative 15, if that equals 30, I am right. Two negatives make a positive, chop chop. 15 plus 15 is 30, so 30 equals 30. So I'm right. Okay, let's take a look at this third example. I see 2/3 x equals negative 30. I want to isolate x, so I'm going to multiply by the reciprocal of 2/3, which is 3 over 2. So if I multiply by 3 over 2 on one side, I have to do that to the other. And when I do that, you'll see that those 3's cancel out and the 2's cancel out, which is good, and I'm just left with x, which is what I want. And now on the right-hand side, negative 30 times 3/2, that's really like negative 30 over 1. And if I multiply fractions straight across, I get negative 30 times 3 is negative 90. 1 times 2 is 2, and negative 90 over 2 simplifies to be negative 45. And then I can check my work here. And I can say is 2/3 times negative 45 equal to negative 30? Well, yes. 2 times negative 45 is negative 90. Negative 90 divided by 3 does equal negative 30, so I know that I'm right. Okay, we'll continue on. Question 4, negative 1/3 times x equals 7. So I want to get rid of that negative 1/3 in front of the x that's being multiplied by it. So I'm going to multiply by its reciprocal, which is negative 3 over 1. So again, I just flip that fraction to find the reciprocal. And those terms cancel out, same with the negatives, but I have to multiply by negative 3 over 1 on the right-hand side. Negative 7 times negative 3 is a positive 21 over 1, and I don't need to write that because anything over 1 is not needed to write. And if I check my answer, negative 1/3 times 21, that equals negative 7, I'm right. And yes, 1/3 of 21 is 7, and then adding on the negative would be negative 7. So again, finding the reciprocal of a number is just flipping that fraction. And last example here, I am going to isolate my variable x. So I see that I have a negative 14, so I'm going to add 14 to both sides. And I'm left with negative x equals negative 4 plus 14 is 10. And now I have to isolate my variable without a negative in front. I'm going to divide by a negative or a negative 1, and I get x equals negative 10. So now if I check my answer, negative 14 minus negative 10, if that equals negative 4, I'm right. Two negatives make a positive right there. So negative 14 plus 10 is indeed negative 4. So I know that I'm right. So again, today was looking at examples where we had a negative variable, or we also had fractions within our equations. Thanks for listening. Have a great day. Bye.